Hi, this is my lab 4 on bar magnets. So for this lab, we wanted to observe the behavior of the magnetic field produced by the bar magnet. This was by measuring the magnetism on the axis and the off axis in the magnetic field produced by the bar magnet. And we used both a real and a computational model to observe this. The key concepts we use are the Biot-Savart law, which is this equation right here, and then we also use the magnetic field parallel to the x-axis, and then the magnetic field perpendicular to the x-axis. So for the experiment, we got a meter stick and we aligned the phone facing north. And for the system is the phone and the bar magnet, and the surrounding is everything else, including the Earth. So for our on-axis experiment, we used the phone and the magnetometer, and the meter stick, and we moved the phone across the meter sticks and recorded the BX, and here it records the magnetic field in the X direction, and the graph right here shows the results. Then we have the experiment for the off-axis, and for this we moved the phone across the ruler until B equals 100 microTs. And then we recorded the position, and then we moved the phone, which was the vector D00, and then we moved the phone to vector D perpendicular 0. And then we recorded the bar magnet, which was the net minus the Earth. And then here are the results in the table from the off-axis experiment. Here are some screenshots from my GlowScript code. So the one on the left, we have the magnetic field calculations. This is derived from the Biot-Savart law formula, which I then translated into code. And then on the right, I have all of our initial conditions and the average perpendicular from my experiment. Here are my computational model results. You can see the arrows we have that represent the magnetic fields at all the different positions, and then you have down below right under it you have the values of the vectors. Some possible error sources could be due to the iPhone's magnetometer, which probably was not entirely accurate because it was a phone app we used and it just will not always be completely accurate. And then, of course, we also have human error, just with the measurements and calculations with rounding and the movement on the meter stick. And then also we have Earth magnetics field. It probably had some effect on the measurements, whether it wasn't entirely facing the right direction or the values were different than what we recorded them to be. And finally, for our conclusion questions, the first one is, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So if it wasn't pointing north and instead was some other directions, the Earth magnetic field would influence the measurements in all three directions now, and it would produce just different values than we got. Now it would be more magnetic fields and angles affecting our measurements, so it would obviously be different. And then for what if you were to stick two identical magnets together end to end and run the experiment again, how would your measurements differ? If you stuck both magnets together to produce, you would produce a new magnet that is twice as strong, because if you connect them with the proper negative end and positive end in one giant one, it would just be a bigger magnet. And this magnetic dipole moment will add together, resulting in a new moment in the same direction but twice the magnitude. So again, all the magnetic field measurements would just be doubled.